I think Ramesh is only present. Ramesh, are you able to see the screen? Ramesh, am I audible?
Good evening, sir.
Okay, thank you.
Hello.
You are able to see the screen or not?
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. So let us begin today's session. And so in today's session, we are going to see the economic aspects in power distribution system planning. And we will, so as usual, we will see some concepts and some expressions that we need to solve the problems for the current assignment number 9. And then after that, after going through a recap, we will solve the problems. So just begin with the theoretical parts. So if you talk about the economic aspects, there are three costs related to this power system distribution system planning. First one is embedded cost, then marginal cost and incremental cost. So what is the meaning of this embedded cost, marginal cost and incremental cost? So you can refer this book, Ashley Will's Power Distribution Planning, from where I have put down this meaning of from where I have put this figure. They describe embedded cost, marginal cost, and incremental cost. So this is the operating point. And if you're starting from this, uh, if you this all the initial costs and till this point, all this cost income incomplete as embedded cost. So we will see how we can define embedded cost, and marginal cost is just the slope at this operating point, and incremental cost, that means that if you have some increment or decrement, so what does the cost what will be the impact, what will the cost for the uh, for this increment, so that relates to incremental cost. So here this hourly cost of losses for power shipped through a substation transformer as a function of load. So x-axis we have load, and this y-axis we have hourly losses cost in dollar. And this currently substation is loaded, substation transformer is loaded to 45 MVA. This point is 45 MVA. So this is 45 MVA. And if you look on the cost, embedded losses cost, then it given as 1.73 per MVA or per megawatt. And marginal cost is the slope, and you can see this marginal cost of the losses at the same point is 3.70 per megawatt or MVA. And incremental cost for an increase in load, like suppose here it went to 55 MVA, then for this increment the losses cost will be, incremental losses cost will be $5.9 per MVA. So if, here I have written down this embedded cost is that portion of the cost that exists in the current plant system or configuration or level of use. Depending on the application, this can include all or portion of the initial fixed cost and all or parts of the variable cost. So includes all this. We know that there are two types of cost. One is fixed cost and variable cost. So this includes all this initial fixed cost that we used to have in providing the power, and the variable cost to run the plant or to run the substation, that all combines in this embedded cost. Marginal cost is the slope of the cost function at the current operating point. So you have a cost function for operating the for operation of substation, and that cost function, if you take the slope of that cost function, that gives you, based on that operating point at that current operating point, that gives the marginal cost. And this point is usually the point at which the current embedded cost is defined. So current embedded cost for this operating point, and if you take the slope at that operating point based on the cost function, that will give you the marginal cost. And then we have incremental cost. So incremental cost is the cost per unit of a specific jump on increment. For example, the incremental cost of serving an additional 17 MVA from substation, or the incremental cost of losses when load or feeder decreases from 5.3 to 5 MVA. So here we have increment of 10 MVA. So that can be other thing, that can be uh, variable. So here you can see that what could be the incremental cost if this substation is serving additional of 17 MVA from the substation uh, upon that operating point, or the incremental cost of losses when load on feeder decreases. It is not necessary that it should always increase. It may decrease, and that it decrease from 5.3 to 5.0 MVA. This is just example. Marginal cost and incremental cost both expresses the rate of change of cost with respect to base variable. So here you can see this marginal cost and incremental cost both expresses rate of change or a slope. So these can differ substantially because of discontinuities and non-linearities in the cost relationship. So they differ based on the discontinuities and non-linearities in the cost relationship. So it is very important to distinguish correctly and use the two. Use both of these, marginal cost and incremental cost. So for example, this marginal cost has a slope, that cost per unit change, and an operating point. So marginal cost, we have two data. One is the operating point and what its slope of that cost function. And incremental cost has a slope and both from and to operating points. So initial operating point and final operating point, it should be provided for finding the incremental cost. Or you can say that an operating point and increment. So here this 45 MVA to 55 MVA is given like initial operating point and then final operating point. And like and again, suppose they are providing increment that is similar. 45 MVA is the initial operating point and 10 MVA is the increment. So I hope all these three costs are clear. Means immediate cost, marginal cost, and incremental cost. Increment cost is the all initial cost and all initial cost, fixed cost, and is the summation of initial cost, all initial fixed cost and variable cost based on the operating point, while this marginal cost is the slope at that slope of the cost function at that operating point, and the incremental cost is that cost when there is an increment, or you can say there is loss of load also from that operating point. So what will be the incremental cost? So both the marginal cost and incremental cost are the change in the operating points, or you can say that it is just like slope, it is derivative term. You can refer this marginal cost, incremental cost based on the discontinuities and non-linearities in the cost relationship. And this marginal cost has slope, cost per unit change, while this incremental cost has slope and both from and to operating points. So coming to the next part where we will see the what is the worth of a some worth of a uh, something, what should be the present worth factor, what should be the future worth factor based on the discount rate. So this the present worth factor is related to the discount rate, where we have this P the present worth factor and D the discount rate. It is defined as P equal to 1 upon 1 plus D. So this relation we need to know. And if you have future worth of with the if the future worth the value of money required T years later, and present worth with the present value of money required for expensive planning, then future worth and present worth can be expressed as present worth equal to future worth into worth factor upon to the power T, where T is the number of years. So these two relations are important, where we will evaluate the value of money at present or at later period of time. Now then we have another term, that is levelized value. So levelized analysis is a method of applying time value of money analysis to initial and future cost to develop equivalent constant annual cost. So this is important. If you have equivalent constant annual cost, then what should be the amount of money at some stage, at some year, at some after a year of time, or at present. So levelized value of Q over T years can be denoted as Q into D into 1 plus D upon T to the power T upon 1 plus D to the power T minus 1. So this is levelized value of Q over T years, and this Q is the present worth. So if this amount you have right now, so what is the levelized value of Q over T years? So you can find using this relation. Means levelized value means what amount you should have equivalent annual cost. So if you have right now 10 lakh rupees now, and after 5 years, it has certainly based on the discount rate, based on this discount rate, this amount will change. So that amount, how you will make equivalent annual cost. So that will certainly something like 10 lakh rupees right now. After 5 years, it should be like 15 lakh. So what should be equivalent constant annual cost? So if you use this lesson, it will give you some value like 3 lakh, 3.5, 4 lakh, like that, or 2.5 or 2 lakhs. So like that, we will see we will see problems based on this, how we can find the levelized value of Q over T years. So this expression is also important. And in this lesson, Q is the present worth factor. Yes, any doubt?
Levelized value means actually future cost, or
No, it is not future cost. It is the equivalent constant annual cost.
yeah, it
Means right,
include losses or any expenditure in that
like
sense.
yeah, like if you have this let's suppose this is the initial year, that like T equal to 0, and T equal to 1 after 1 year, and T equal to 2, and T equal to 3. So initially, if you have 10 lakh, and after based on the discount rate, it will depend like this. If you find this future worth, then future worth equal to present worth ten lakh present worth upon p to the power t. Yes. So this amount you having after 3 years. So like so what should the amount of money you should be such that you will accumulate so that you will get this amount of money. So this so at the after 3 years, so how you will get this amount of money? So it's if you use this relation, then it will like if you get suppose 15 lakhs or 3 lakhs, 15 lakhs or 20 lakhs, then it will be like 3.5, 3.5, so 3.5. So based on this 3 years, so what should be the equivalent amount of money that you will get this future worth of this amount? So it is like that equivalent constant annual cost. If we will see the problem based on this, then it will be clear to you. So it is the equivalent constant annual cost. Don't confuse with like the future worth. And Q is the present amount of money that you know that this amount of money right now. So what is the future worth and how you can find its equivalent constant annual cost for that amount of money. Now coming to this next part, that we will see some basic of optimization, and there are many questions based on the optimization, and most from optimization part many problems are theoreticals only. So what do you mean by optimization? Optimization is to either to maximize or to minimize certain objectives which can be translated to some mathematical function called objective functions. So the goal is to either maximize or minimize certain objectives which can be translated to some mathematical function, and it is also it is called as objective function. And objective function for the optimization problem can be of either single objective optimization function or multi-objective optimization function. In single objective of the optimization function, you can denote it like minimize fx, where x is called as decision vector, which constant of a number of decision variables, optimization variables, or problem variables, or simply variables. So this is you can denote single objective optimization function like minimize fx, where this x is called decision vector, which consists of number of decision variables or optimization variables or problem variables or simply variables. So this x can be single variable, then you can also call this as single variable objective function. And when this x is multi-n-dimensional vector, then you call it as multi-variable optimization function. Now this is for single objective optimization function. Now if you look on multi-objective optimization function, then we have m number of objective function, and that can you denote like minimize f1x, f2x, and so on till fnx. So you can write fnx. So we have written m here. So you can write it as m. So it's better to change here. Now for single objective, or that you also call it as mono objective optimization problem, there are two different types of optimization problem. One is unconstrained optimization problem, other one is constant optimization problem. And constant optimization problem is that you have to just define that minimize effects and there is no constraint on the variables. So and in other parts, for constraint optimization problem, you have given this function that you need to minimize or maximize, where this is subjected to gx equal to 0. This gx equal 0, if there is equality sign, then you see this equality constant, or some function gx less than equal to 0 or greater than equal to 0, then that we called as inequality constraint. So in constraint optimization problem, the solution which satisfy the constraints are called feasible solutions, and the best feasible solution in view of the objective function is called the optimal solution. So for constant optimization problem, like there we have seen constants also can be of two types. One is equality constants, where this constant function is equated to 0, while inequality constants where constant function is having inequality sign, either less than or greater than equal to 0, or simply less than or equal to less than or greater than 0. So in constant optimized problem, the solution which satisfy these constants are called feasible solutions, while and the best feasible solution in view of the objective function is called as the optimal function. And if after getting the optimal solution, there are two types of solution. One is local optimal solution, another is global optimal solution. So local optimal solution, you also call it a local optima, and global optimal solution, you also call it as global optima. Local optima means the best solution among its feasible neighborhood solutions, while global optima, the best solution among all feasible solutions. Now let us see types of optimization problems. So based on the nonlinearity, based on the convexity, based on the differentiability, and based on the nature of decision variables, it can be it can be it can be categorized as, like, first, based on the linearity, it can categorize a linear optimization problem or non-linear optimization problem. Based on the convexity, these all are this optimization function or objective function. These all based on the objective function, you are defining this type of optimization problems that you need to minimize or maximize. And based on the convexity, we have convex optimization problem or non-convex optimization problem. Based on differentiability, differentiable optimization problem or non-differentiable optimization problem. And based on the nature of decision variables, based on the nature of decision variable, we have continuous, discrete, or mixed integer optimization problem. Now, if you see the solution strategy for optimization problems, there are of two types. First one is mathematical logic based algorithms. Another one is meta heuristic algorithms. So in mathematical logic based algorithms, we have mixed integer programming, branch and bound, Bender's decomposition, dynamic programming, and nonlinear programming. In meta heuristic algorithms, we have expert system, branch exchange, network flow programming, simulated annealing. And in meta heuristic meta algorithms, we have the one of the popular categories, that is population based meta heuristic algorithms, that comes some of the important solution strategy for optimization problems that nowadays being very famous or very widely used. And these are genetic algorithm and colony optimization, artificial immune system, particle swarm optimization. And if you see in this population based meta heuristic algorithms, I think many of you heard these two terms very frequently: genetic algorithm and this particle swarm optimization. These are very famous and very widely used in the optimization problems, not in power system and in other field also. So if you look on the summary of solution strategy for optimization problem, then In most of the multi-objective planning, the population-based meta algorithms are used. Right, I already told you this population-based meta heuristic algorithms are used because this has multi-point search that helps to obtain set of Pareto approximation solution in single run, and they can handle nonlinear, non-convex, non-differentiable problems effectively. And they also don't suffer from the curse of dimensionality. So these mathematical logic-based algorithms, they suffer from the curse of dimensionality. So if you look on the drawback of mathematical drawback for this mathematical logic-based algorithms, these they suffer from the curse of dimensionality. And to overcome this drawback of mathematical logic-based algorithms, these mathematical meta-heuristic algorithms came, and they don't suffer from the curse of dimensionality. But the drawback of this meta-heuristic algorithms is that the convergence is not always granted. So the convergence for this meta-heuristic algorithms also drawback is that convergence is not always granted. So this is all about summary of today's session. We have seen the economic aspects of power distribution planning, and we have seen basics of optimization. If you know these basics, means these are initial slides of optimization, then you have a overview, means what is optimization and what are different types of optimization can be, and what are the solution strategy, means in broad view how you can get the solution optimization problems, and what are the ways, what are the strategy, what are the techniques for solving an optimization problems. You can see these slides where we have classified the solution strategy for optimization problem. Now we will start solve the problems. So the first problem is that okay. So the first problem is that a utility needs 18 lakh right now to do the expansion of a substation. How much money will be needed 7 years later to do the same expansion? Assume the discount rate is 9%. And the options are provided here. Those who are getting answer, you can type your answer in chat box. And I also solve parallelly. So what are the things we have given. Utility needs 18 lakh right now. 18 lakh right now means this is present worth they have provided in the problem. So rupees 18 lakh is the present worth of money that we require to do the expansion of substation. How much will be needed 7 years later? How much money will be needed after 7 years? So T is given as 7 years. To do the same expansion, assume the discount rate as 9%. So D is given as 9%. So in percentage, so we have to write in decimal 0.009. So these things are given. You need to find the future worth. So this is very simple. And we have seen one expression where this present worth and future worth is related as this expression present worth equal to future worth into P to the power T. So where P is related to discount rate, present worth factor, and it is 1 upon 1 plus D. Now you substitute all these values, you will get the answer. Present worth is 18 lakh. Future worth we need to find, and P to the power T will be 1 plus T. So D is 1 plus 0.09. T is given as 7 years. So did anyone get the answer? So did anyone got the answer? Are you are watching IPL match?
B.
Yes, 32 lakh 90,407. Very good, Ramesh. B is the correct answer. So P is the present worth factor. So in the problem also they write, they give you the present worth factor. So from the present worth factor you will find the discount rate. Like into 1.09 to the power 7. So it will give you 32 lakh 90,470. So B is the correct answer. Clear any doubt, anything you want to ask? Otherwise, we can move to the next problem. Yes, Sihab, you are also correct. B is the correct answer. Ramesh, your answer is also correct. Now coming to the next problem. So here a distribution companies has two available strategies to do network reinforcements. A strategy A involves investing now in network reinforcement, and strategy B involves spending a fixed amount each year over a few years in the future. If the company can spend 10 lakh right now using a strategy A, what constant amount should the company invest every year to achieve the target in 5 years, assuming the present worth factor is 0.9? First, I would say that read the question carefully, then you are able to solve this problem. So this question is really little bit tricky problem. So I will give you hint here, and then you can move, you can solve this problem. So two strategy are they can follow. The strategy A, in which investing now. Strategy aim is that you need to invest right now. You need to invest in present at the present moment of time. A strategy involves spending a fixed amount each year over a years. So a strategy B involves a fixed amount each year over a few years in the future. If the company can invest 10,000 right now, 10 lakh right now using a strategy A, so present worth they have provided. So given is the present worth that provided as 10 lakh. What constant amount should the company invest every year to achieve the target in 5 years, assuming the present worth factor as 0.9? So you can solve in this way also, because we know the relation present worth equal to future worth into p to the power t, right? So you know the present worth, that is 10 lakh. And in a strategy B, we have to invest each year. So let the amount of time, amount of money is future worth into, and P is also given. P is given as 0.9 present worth factor. So first year we have invested 0.9 in 5 years. So invest in 5 years. So future worth into 0.9 square plus future worth into 0.93 square, future worth into 0.94 square plus future worth into 0.9 to the power 5. Sorry, 0.9 square, 0.9 to the power 3, 0.9 to the power 4, and 0.9 to the power 5. So if you solve this, So anyone got the answer?
Yeah, B, sir.
What?
B.
B. Yes, B the correct.
Actually, what is this question? Choose strategic plan.
Yes.
Hello.
Yeah.
About the, can you explain more, sir? Answer I got as per this equation. Answer is B. But what is the meaning of this question? The utility have choose strategic plan.
Yeah. You really have two strategy plan, and in one strategy they can like you involve they are investing right now in second plan. You are investing such that equal amount of time every year, equal amount of money every year. So equal amount of money we have taken as FW future board. So each year you are spending this amount of money. So what is the equivalent amount of money? So present worth is 10 lakh. So future worth. So first year, after first year you will be having based on discount rate. Future worth will be future worth 0.9, and in second year again this amount has been invested. So future worth into 0.9 square, and in third year also this is invested, and fourth year also this is invested this amount of money, and fifth year this is also invested. So all you accumulate. So the present amount of money is 10 lakh, and now you can find the future worth of money that we have invested each year for the 5 years, and that amount of money is constant. You can also solve for this levelized cost, right? You can also solve for this levelized cost,
Okay.
right or not? So this present worth is given 0.9. So 1 plus t. Yes. So that I want to correlate. So you can also directly apply the levelized expression. From there it will clear. See, is the question clear to you or not?
Actually, I didn't get that. Actually, this company having two plans.
Yes, means I just told you in the beginning we have levelized cost. So you apply this expression also, you will get same answer.
Okay. Same answer we will get.
Here, so you directly apply this expression that I was right now calculating, and for both the way you will get the same answer. So in levelized cost, like here I have shown you, initially we have 10 lakh 10 lakh money. So one strategy that you invested 10 lakh right now. Another strategy that you want to invest equal amount of time for this number of period. Not write this. Don't write this as 0. So take it as 1, 2, 3, 4. So 4 years of time. So first year you invested 3.5, and for second year 3.5, and for third year 3.5, and fourth year 3.5 lakh. So these like you invested equally, and this amount will be equal. So 3.5 lakh into 4 is equal to future worth of 10 lakh. The future worth is what? 10 lakh upon p to the power t. So that is the thing they want to ask in this question. So we will solve this problem by two ways. That this you want to invest equal amount of money every year, and you just invested in the first year, and and so that amount of money will be equivalent for those that have invested for equal number of equal amount of money each year. So right now, so here we have got this answer 10 lakh. This is future worth, and this is 3.68559. So future worth means equal amount of money that in a strategy they want to invest. So 2,71,327. So this is the answer. So answer is B. So if you want to note denote on the table, like this is this way. So top, let us take a strategy A. In a strategy A, they are telling that company has spent rupees 10 lakh in the first year, and they have invested 0 in the next 5 years. So this is first year. This is second year. This is third year. This is fourth year. And this is fifth year. So in a strategy A, company invested 10 lakh to do some pension. In a strategy B, utility has done what? They have invested some amount of money equally in each year. So this we take as future worth. Now this you can, I have taken future worth because the expression from which we are solving, that's why we have taken future worth. So you can also take it as X. So X amount of money we have invested each year. First year, second year, third year, fourth year, fifth year. So X is we have taken future worth. And for in a strategy B, they have not invested in second year, third year, fourth year, fifth year. So now they are asking what is the X amount of money that is equivalent to 10 lakh amount of money invested in first year. That is the question only. Sihab, did you get the problem or not?
Now it is clear, sir.
Yeah. So it is very simple. And this X is the levelized cost only. So this is levelized cost.
Okay, okay. But this problem we cannot calculate through that equation.
Yeah, that we will solve that with the other question also. So you will get the same answer.
D is not available with us.
So D you can find with the present worth factor.
Okay, okay, okay.
let it be. So we are going to use another method that we know levelized cost. So second method you can write second method. So second method we know the levelized cost of Q for T years, levelized value of Q over T years equal to Q into D into 1 plus T upon T and 1 plus D into T minus 1. So this expression we know. Now we have to find the levelized value. So I have written this cost, so it's better to write levelized value. So now tell me, what are things given based on this expression? What is the Q? Anyone can tell? For this question, what is the Q? Yeah, Ramesh, you can guess.
10 lakhs.
Yes, correct. So Q is present worth only. So Q is present worth. Q is given as 10 lakh. And we have given T number of years. Number of years is given as 5. Now this present worth factor is also given, that is P, and P we write as 1 upon 1 plus D, that is given by 0.9. So from here we will find the D because we need D. So 1 plus D is 1 upon 0.9. So you will get 10 upon 9. 1 plus D is also important, and D you will get 10 upon 9 minus 1. So 1 upon 9. So D you get 1 upon 9. Now you just put this expression, you will get the same answer. So levelized value equal to 10 lakh D is 1 upon 9 and 1 plus D is 10 upon 9 and 1 plus D is 10 upon 9. E is 5. So it will be 10. Numerator will be 0.188167 and denominator will be 0.6935087. So it will be 2,71,027 is the levelized value. So you got the same answer or not? See how about Ramesh? Anyone can answer? I think now it is clear to you. Ramesh?
Yes, sir. Clear, sir. Clear. We got same answer of both method.
So you can also correlate this problem with your real life. So this is very realistic now. Many of you are doing, I don't know whether you are doing or not. You know lump sum or SIP?
Yes, sir. We are investing in SIP.
Yeah.
Yes.
So this is similar when this is similar now. One person is doing lump sum of 10 lakh and they are asking that after 5 years this much is the interest rate, and based on this interest rate what amount of money you should invest annually that you will get the same amount of money those who are getting by doing the lump sum. Am I correct or wrong?
Correct, sir. Correct.
Yeah, so this is a very means like you can relate with your those who are investing in the stock market or what this mutual fund, NPS, many funds are there. PPF, so many funds are there. So this is this you can correlate with your real life. Those who know about lump sum and this SIP, and SIP is, if you see here, it's very difficult to just invest 10 lakh first year, that is lump sum, and somehow a person can manage 2,71,000 each year, and both person will get the same amount of money if this is the interest rate or something they have provided. So this is, you can say, levelized value, you can say it as SIP or systematic investment plan, or this 10 lakh you can say it as lump sum amount. So let us move to the next problem. So in this problem, a utility estimates that the distribution system should be reinforced within a year considering the expected increase in power demand. However, the contractor provides the utility with two options for network reinforcement, either to make network reinforcements now or a year later. If the reinforcement is to be done now, the contractor demands 90,000, and if the reinforcement is done a year later, the contractor demands 1 lakh at the end of the year. Consider that utility can pay in both options and does not get any returns if it chooses network reinforcement earlier. Which of following is a suitable decision for the utility? If the present watt factor is 0.88, it is better to do the network reinforcement now than a year later. If the present watt factor is 0.88, it is better to do reinforcement a year later than now. C option is discount is 10%, it is better to do network reinforcement a year later than now. And D option is, if the discount rate is 10%, it is better to do network reimbursement now then later. So we will see both the cases when the parent board factor is given and when this discount rate is 10%. So let us first see this first case, what they provided. So first option, in that they have given that present board factor is 0.088. So T is also given. T is a year later. So T is 1 year. So we know that present worth is future worth into P to the power T. So future worth is present worth we have given. Present worth is 90,000 and P to the power T 0.88. So future worth is rupee 1,02,272. So if you see like present worth 0.88, then means contractor is demanding only 8 lakh, right? Demanding 8 lakh at the end of year. So but you are seeing that if you give 90,000 right now, then its value after 1 year is 1,02,000. So since rupee 1,02,272 is greater than rupee 1 lakh, so it's better to invest. It's better to give the amount to the contractor after 1 year. So here it's if the parent board factor is 0.9, so it is better to do network reimbursement early year later than now, right? So this is the present worth. Present worth is given rupees 90,000. So based on the present worth of money, you can find that whether this amount of money is greater than contractor demanding after 1 year, or it is same, or it is less than that amount of money demanding. So if it is less, then it's suppose this money is coming less than 1 lakh, then it's better to give right now. If money is coming greater than 10 lakh, so it's greater than 1 lakh, it's better to give at the end of year. So here, like they in this question, they want to tell that you should be smart based on the inflation rate, whether you should give the money right now or you should give the money at the end of year. From the inflation rate, you can find the future worth of money. Like contractor is demanding right now 90,000 rupees, and after 1 year, if you give the money for the same work, the contractor is demanding 1 lakh, and you know the inflation rate. So from the inflation rate, you can find the future worth of present money. So finding the future worth of present money, that is coming as 1,02,000. So it is greater than 1 lakh. So it's better to give at that time, because they are demanding less money based on the inflation rate. Because 90,000 value will be 1,02,000 after 1 year, but contractor is demanding only 1 lakh. So what is the profit of yours? The profit is 2,270 to the utility. So in this case, the profit will be 2,272 for the utility. because contractor is demanding less money than the money you are giving to him. Now let us see the second case where they have told about the discount rate. So second case, let us find. So discount rate is given as 0.1, 10%. So from the 10%, you can find the present worth factor, that is 1 plus 1 upon 1 plus d. So 1 upon 1 plus d is 1 divided by 1 plus 1. So we will apply the same expression, present worth factor equal to future worth, present worth equal to future worth into e to the power t. So now we know the present worth of money, that is 90,000. Equal to future worth and present worth factor is 1 upon 1. So from this future worth is coming as 99,000. Now see, this 99,000 is less than 1 lakh. So if you give 90,000, then its money after 1 year will be 99,000. But the contractor is demanding 1 lakh. So whether you have to give right now or you have to provide the money later. Tell me. So in C or D is the correct. So this is multiple select question. I forget to tell you. This is multiple select question. So Ramesh, did you get my point or no? If the discount rate is 0.1, then the future worth of 90,000 is 99,000. But the contractor is demanding 1,000 after 1 year. So whether you want to give right now or 1 year later.
1 year later.
No. I think you didn't get. 1 year later, how? This earlier your money was greater than that demanding. So it's so you have profit of 2,000. But here, if you give 1 year later, then you are giving 1,000 from your pocket because your it is coming 99,000. So you should give right now. So D is the correct answer. So here the utility will make profit of 1,000. If they give right now. If they give 1 year later, then you have to give 1 lakh. But if you give 90,000 to him, then you can make profit of 1,000.
Yes, correct, sir. Correct.
Hmm. So this question is little bit you have to understand based on the value of money, later period of time or present period of time. You can either solve by present value. I have solved using this future worth. You can solve by present worth also. Future worth is a little bit okay for me. You can easily understand. Means if I give him right now 90,000, then after 1 year this amount will be, if this present worth per day point rated, this amount will be equivalent to 1,02,272. So it is greater than 1 lakh. So is greater than 1 lakh, so it's better to give later period of time, because this value of that 90,000 I have put in bank, that will become equivalent to 1 lakh 2,272. So I have profit of 272. So I will give 1 year after that. Now in the second case, if the discount rate is 10% or 0.1, then if you if this 90,000 money will be equivalent to 99,000, and later after 1 year the discount is demanding 1 lakh, and I know that after 1 year this amount will be only 99,000. So it's better to give right now, because I know that I have to give 1,000 from my pocket, because after 1 year this 90,000 will become 99,000 only, not 1 lakh. So it's become good to give right now, because contractor has two conditions: either you give 90,000 right now, or you give 1 lakh after 1 year of after 1 year of 1 year period of time. So let us move to the fourth number problem. So here the distribution network requires 15 lakh for network reinforcement. The planning process is initiated 5 years later. Considering the present worth of 0.88, what will be the levelized cost for the planning horizon of 5 years? So this is from the levelized value of money. So you have data, you solve problems. I am giving you 1 minute of time. Then I will solve the problem. So today 3 people are present: Ramesh, Sihab, and Guddu. So let me start to solve it. So what are the things they have given? So distribution network requires 15 lakh for network reinforcement. So present worth of money is given. So for levelized cost expression, we write present worth as Q. So it is equal to rupee 15 lakh. With the planning process is initiated 5 years later. Sorry, so this is not present worth, this is future worth. I am doing mistake here. This is future birth, because this money is after 5 years late. after 5 years. This is future worth. This question is also a little bit tricky. Number of years. T is given as 5 years. And present worth factor is given as 0.88. So we know that in levelized value of Q for 40 years, this present worth is required. First, P equal to 0.88. So from here, we will write P equal to 1 upon 1 plus D. So it is 0.88. So D you will get as 1 point 13636. Now we need to find present worth for the planning process. That is Q. Q equal to future worth into e to the power t. So future worth is 15 lakh. P is 0.88 and number of years is 5. So Q you will get as 7 lakh, that's present worth of money. 7,91,598. Right. Now you apply the expression, you will get the answer for levelized value. So we know the expression for levelized value. Levelized value of Q for T years equal to Q into D into 1 plus D upon T upon 1 plus D upon T minus 1. So levelized value equal to, so Q is rupees 7,91,598. D is 0.3636 into 1.13636. D is 5. 1.136. 5 minus 1. We will get rupee 2,28,588. See the correct answer. So you can solve in another way also, that we have solved this present worth, future worth expression. Any doubt in this problem? Ramesh, you have any doubt in this problem?
No, sir. Clear.
Okay. So with no doubt, then we can move to the next problem. So in this problem, they are asking which of the following statements is correct about cost evaluation involving embedded cost, marginal cost, and incremental cost. So we will see each equations and each option, and then we will decide. So this is multiple select question. More than one options are correct. So in the first problem, in the first option, embedded cost involves all the initial cost, all are part of the variable cost for a plant system configuration. So it is correct or wrong? We have seen embedded cost, marginal cost, incremental cost. So A option is correct or wrong? That only you have to tell. Ramesh. So if you look on the this slide, so we have denoted this embedded cost. We have written about embedded cost, which is you can see that depending upon application, this can include all the initial cost or variable cost. So this is correct. So A option is correct. From here you can tell that A option is correct. Now let us see the B option. Both incremental cost and marginal cost depend the rate of change with respect to given base. However, the marginal cost depend the operating point, while the incremental cost is defined for a specific increment. It is correct or wrong? So for this statement also, I will give you hint. Go to the first slide. So this is also correct. So if you read these two statements, then it is clear to you. So both incremental and marginal cost express the rate of change of cost. So this is correct with a given base variable with respect to a given base variable, but they differ because of discontinuities and continuous cost relationship. And you can say that it has slope while incremental cost is defined for a specific increment like from and to operating points. So both A and B are correct. C option is both incremental cost and marginal cost depend on the rate of change of cost with respect to given base variable and are equal to for highly nonlinear cost function. No, this is unequal because when they are having nonlinear cost function. So this is incorrect. Incremental cost is the cost per unit at the current increment point. It is incorrect. This is marginal cost. It is the marginal cost with the cost per unit at the current operating point. So let us move to the next problem. Which of the following statements are correct about deterministic and meta-heuristic optimization problem? So A option is meta-heuristic techniques are better suited for multi-objective optimization problems due to the ability to explore a large solution space, while deterministic techniques struggle with higher dimension problems. So it is correct. So A option is only correct because deterministic techniques struggle with curse of dimensionality. So A option is correct. Suffer from the curse of dimensionality. Determinist techniques are more effective in high dimensional solution space as meta-heuristic techniques are suffer from the curse of dimensionality. This is incorrect. Meta-heuristic techniques don't suffer from the curse of dimensionality and it is more effective in high dimensional solution space. Both meta-heuristic and deterministic techniques are face challenge handling. It is also incorrect. Meta-heuristics don't face challenge in handling high dimensional problems. Both heuristic and deterministic techniques cover same rate with no significant difference in their convergence behavior. It is incorrect. Meta heuristic has higher convergence rate in comparison to the heuristic algorithms. Sorry, with respect to deterministic algorithms. So this is also incorrect. So A option is only correct. Now let us see the next problem. Which of the following characteristics encourage the use of evolutionary algorithms for the optimization of distribution system problems? And it is multiple select questions. So more than one options can be correct. So those who are getting the answer, you can type it in the chat box. So for the evolutionary algorithms, first option is C. Evolutionary algorithms can effectively solve multi-objective convex Mason problems or discipline system planning. However, they are not able to tackle non-convexity. So this is incorrect. They are able to track non-convexity, so it is incorrect. Evolutionary algorithm can handle nonlinear, non-convex, non-differential problems effectively and do not suffer from the curse of dimensionality. Yes, it is correct because they are meta-heuristic algorithms. Evolutionary algorithms can provide a set of Pareto approximated solution using multi-point search in a single run. Yes, it is also correct. Evolutionary algorithms are adaptable and suitable for dynamic changes in the distribution network requirements, and convergence is always granted. No, it is incorrect. Convergence is not always granted. So it is incorrect option. So if you see about summary for this, then you can refer this slide. So summary of meta heuristic or you can say evolutionary algorithms, both you can consider same, and you can correlate with the answer. So in the place of meta-heuristic algorithms, you can place this evolutionary algorithms, then it will clear. So for the you can see they can handle nonlinear, non-convex, non-differential problems. So B option is correct. And for drawback, this is convergence is not always granted. So this is drawback where it is saying that convergence is always granted, so it is incorrect. So B and C options are correct for this question 7. Now moving to problem 8. Visual flowing is not a heuristic based optimization algorithms. Options are taboo search, vendor decomposition, simulated annealing, branch exchange. Yes, anyone? Any guess? Ramesh, Shihab, and Guddu? Anyone is present here or not? You can type on the chat box. Ramesh, what do you think? I have, I think in initial slide only, I have provided you the this classification of solution strategy. So you can go through this, then you will able to answer.
B.
Yes, very good. Be the correct. That is not popping out. qualitative. So if you see Bender decomposition, this comes in mathematical logic based algorithms or determinist algorithm. So this Bender decomposition is incorrect. I'm sorry. So it is not heuristic based optimization algorithm. So B is the correct options. And if you see another one like Taibu search, so Taibu search is not listed here. So Taibu search is also a meta heuristic used. So you can write about Taibu search. Taibu search is a commonly used meta heuristic. Heuristic solution strategy for optimizing for optimizing model parameters. It's a meta heuristic algorithm for solving combinational optimization problem. And Bender decomposition comes under this mathematical logic based algorithms. Simulated annealing comes under these heuristic algorithms. So branch exchange also comes under heuristic algorithm. So only Bender decomposition is mathematical logic based algorithm. So let us move to the second last problem. So what are the key characteristics that make dynamic programming a suitable approach for distribution system planning problem? So options are given here. Dependence upon Newton search, dependence upon random variables, performance is not affected by increasing dimensionality and thus easier to tackle multiple and time dependent constraints, overlapping sub problems and optimal substructure. Key characteristics of dynamic programming, if you see, so that is overlapping and optimal substructure. So this D option is correct. Two key ingredients of dynamic programming are Optimal substructure. And overlapping subproblems. So two ingredients are optimal substructure and overlapping subproblem. So this makes an effective, suitable approach for distribution system planning optimization. So firstly, the dynamic programming decomposes a multi-stage decision problem to several overlapping subproblems. Then it solves all the subproblems recursively in a bottom-up fashion. So if you make the diagram for the subproblems, then be like that. This is subproblem 1. And then it is subproblem 2. And so and then complete problem. So it's decompose a multi-stage problem into several overlapping subproblems. So this figure denotes decomposition of a problem into several overlapping subproblems. Now let us see last question. How is position vector updated based on the particular velocity between particles arm optimization? The position is randomly assigned each iteration. The position is updated using a constant velocity value the position is adjusted based on the velocity and time step. The position is not updated based on velocity, but overly based on the global base option. So the position is adjusted based on the velocity and time step. So C option is correct. Now for the current assignment, I will suggest you also go through the previous year of 2023. If you see some problems that is directly given from these assignments, like I will provide you some hint. Like for evolutionary algorithms, they have given the question and incremental cost, also meta heuristic. So I will give you some. This question we have already solved this type of problems. So here one step planning that did not construct load is called static planning. So this question is also in the current assignment. Which of following are meta heuristic optimization problem? So in your assignment, they are asking which of the following are not meta heuristic optimization approaches. This one also, which of the following is an advantage of meta heuristic optimization problem? Optimization algorithms. So this question is similar in your current assignment. Distribution system planning problem is generally a kind of mixed integer optimization problem due to the involvements of. The answer is both discrete and continuous decision variables. Now for 2022, we have solved this present worth and future worth type problems. We have solved some problems based on the levelized value also. So this question, the static planning of power distribution system is. If they ask about dynamic planning, then you can consider based on this understanding. So static planning power distribution system is one step planning without consideration of load growth, while dynamic planning is the multi-step planning with consideration of load growth. So dynamic planning of power distribution system is multi-step planning with consideration of load growth. Meta heuristic optimization algorithm works with. So meta algorithm works with, that is, this question is also from the current assignment, where this meta heuristic works with the nature inspired meta heuristic rules and iterative updating of randomly generated solutions. It is not calculus based mathematical rule. It is not non-iterative direct solution approach. It is nature inspired meta heuristic rules. You can understand from the word also, and colony optimization. Particular, what that is called? This particle swarm optimization, artificial immune system. That's all genetic algorithm that all are based inspired by the nature. So that's why it is nature inspired meta heuristic rules, and these update their values based on the iterations. The advantage of meta heuristic optimization algorithms, it is similar for these evolutionary algorithms, where this can be used for solving nonlinear problems. This can be used in solving problems with nonlinear, with non-differentiable objective function. This can be used to solve problems with large number of variables. So for both meta heuristic and evolutionary algorithms, the advantages are similar. The limitation of meta heuristic algorithms are they cannot always provide global optimal solution. They sometimes provide only local optimal solution. So yes, this is correct. Limitation are they cannot always provide global optimal solution. and this conversation is also not always granted. So this is all for today's session. If you have any doubt, any concern you want to ask, then please you ask.
This week actually some theoretical background as well.
Yes, but in optimization, if you go through this lecture number, I think you can easily solve all the problems. 1 minute. If you go to the lecture number 25, lecture number 20, then all theoretical problems you can easily solve, and all the theoretical problems are very similar. It's like distribution system planning are of two types: static and dynamic planning. From there, 1 or 2 questions asked, and some question are optimization where they have asked about meta heuristic optimization algorithms or these mathematical deterministic algorithms. Mathematical logic based algorithm. So you should know the classification, and then you can solve the problems. In mathematical logic based algorithms, they suffer from the curse of dimensionality, while meta heuristic algorithms, the drawback is the convergence is not always granted. But the question are easier. You just go through these slides that I am provided you. You find that many problems are similar in the current assignment, and many problems are directly asked, like this problem, dynamic planning of power distribution system. Which I think this question is very similar. These are very helpful for solving the current assignment. For your better understanding.
We will go through.
Okay. Okay, then if you don't have another concern, then we can close today's session and we will meet on the next Sunday.
Okay, thank you, sir.
Okay.
Good night.
Thank you for attending session and good night.